What we have here is a simplified demonstration of the phases of the moon. The moon is shown orbiting around the Earth, and the sun is in the far distance in the direction of the arrow. The phase of the moon is determined by the direction of sunlight falling on the moon in relation to our line of sight looking at the moon. Understanding the phase of the moon is a lot like understanding the changing lighting on the little figure standing in the middle. Note that the figure's head also has phases, but you probably didn't see it in those terms because the changing lighting on a person is such a familiar situation. The moon is a sphere, so only one half is lit up by the sun. When the lighting is from an angle, we are seeing part of the lit up half and part of the dark half. When we come around to alignment with the sun, we have what's called new moon. The far side of the moon is lit up and the near side is dark. Furthermore, since it aligns with the sun, it is up in the daytime, so essentially new moon is no moon. If there is a perfect alignment between the sun and the moon at new moon, the moon would cover the sun and we would have a solar eclipse. But since the moon's orbit is actually tilted a bit, a perfect alignment is relatively rare. First quarter moon is when the moon is at 90 degrees from the sun, with the right half of the moon lit up. The phases first quarter and third quarter are labeled by what fraction of the cycle has elapsed since new moon. Full moon could be called second quarter, but it's generally just called full moon. There's a half moon bay in California, but there is no half moon in the sky. What you might think of as a half moon is actually either first or third quarter. Full moon is when the sunlight is coming in over our shoulder, lighting the same face of the moon we're looking at. If the alignment of the sun, earth, and moon is a little too perfect at this phase, we would have a lunar eclipse, where the earth's shadow covers the moon. Third quarter moon is when the moon is 3/4 of the way around the monthly cycle. From the northern hemisphere, the left half of the moon looks lit up, and the right half looks dark. So the moon is in the shape of a backward D. A crescent moon is when the visible side of the moon is less than half illuminated. It looks like a fingernail clipping, especially when it's close to new moon. When the visible face of the moon is more than half lit, we call it a gibbous moon. When the moon is growing from new moon toward full moon, we say it is waxing. When the moon is diminishing from full back to new, we say it is waning. So after the new moon, we have a waxing crescent, followed by the first quarter, then a waxing gibbous moon, reaching full moon when the moon is opposite the sun. Then the sequence is waning gibbous, third quarter, waning crescent, and back to new. When the sun is setting in the west to our right, the first quarter moon would be high in the evening sky. The half of the sky from the setting sun on the right through the first quarter moon around to the point on the horizon opposite sunset is the evening sky. When the moon is full, it rises at sunset, it's overhead at midnight, and sets at sunrise. So the half of the sky centered on the full moon is the late night sky. The half of the sky from the rising sun on our left, around through the third quarter moon to the opposite horizon, is the morning sky. So the phases of the moon are related to the angle of the moon around from the sun, which determines the lighting we see on its surface. And each phase is associated with a particular place in the sky, which determines what time of night it can be seen. Just for your information, this demonstration has a northern hemisphere bias. From the southern hemisphere, we would have to flip everything upside down. The apparent direction of rotation would be reversed, and the appearance of the moon would be inverted. When I first visited the southern hemisphere, I found it very disorienting. I created this demonstration with Visual Python, and I'm distributing it as open source. So some enterprising science teacher or amateur astronomer from down under is free to make their own tweaks to the program to get a southern hemisphere version. To avoid total confusion, however, I will leave it at this description for now.